Today we are looking at the cosine rule. The cosine rule is used for non-right angled triangles when you are given all three sides of the triangle and you would like to find one of the angles, or you are given two sides and the included angle, or the angle between those two sides. There is no ambiguous case for the cosine rule because only sine is positive for obtuse angles in that second quadrant. So we don't have to worry about that for the cosine rule. We label our triangles the same way, and we have two formulas here that you need to be able to use. So first of all, if you're trying to find the length of a side, then you want to have the side by itself, the little letter. Now there's different versions of this. For each of these ones, I've made A the subject, but you can relabel your triangles to make this fit if you need to. So if a is what little a is what I'm trying to find, it's a squared equals b squared plus c squared minus 2bc cos a. If you are trying to find an angle, then we want our angle by itself on the left-hand side of the equation. So that's cos of capital A equals b squared plus c squared minus a squared over 2bc. Now I'm just giving you those two formulas, but if you would like to have a bit of practice, a little bit of fun here, you could start with the side length formula and rearrange it to get the cos A by itself and see if you can actually get that second formula. That would save you having to memorize it, but it does take a bit of extra time, so it probably is better to memorize both of them, given that time is very important in tests. So, example number 1. Find the third side of a triangle, ABC, given that little a is 5, little c is 11, and capital B is 73. Let's draw a diagram. Any random diagram, not to scale. We're going to have A, B, C. Little a is 5, little c is 11, and capital B is 73. So by seeing it on the diagram, you can see that I have got two sides and the included angle. So I can use the cos rule to find a side. So the cos rule is a squared equals b squared plus c squared minus 2bc cos a. Now unfortunately, I'm not trying to find, I haven't got capital A, I've got capital B. So you could go and relabel the triangle if you want to, or you could rewrite the formula if you wanted to. But the shortcut is you don't need to do that. You can substitute straight in. Now, I'm trying to find the little b over here. Okay, so the little b, the b squared, is going to be equal to, and it's always the other two sides. So it's going to be 11 squared plus 5 squared minus 2 times 11 times 5. And then it's just cos of the angle, which is cos of 73. Okay, and you type all that in your calculator, which gives 113.839 ... There's a few more decimal places there, but you must also remember to square root that to get b by itself. So that's 10.67 if I do it to 2 decimal places. Okay, that's it. That's the cos rule to find a side. Let's have a look at example 2. Find the smallest angle in the triangle with side lengths 5, 8, and 11. So again, draw a diagram. So 5 I'm going to put there, 8 I'm going to put there, and 11 I'm going to put there. Now the smallest angle is always across from the smallest side. So 5 is the smallest side, so that means that this angle here is the one that I want to find, or perhaps I should call that the A. Okay, so that means I'm trying to use the angle formula, cos A equals b squared plus c squared minus a squared over 2bc. So the labeling again is not critical here, but the important thing is that the A, the one that you're subtracting here, is the one that is across from the angle that you're trying to find. So the 5 has to be the A, the B and the C are just the other two. So when I sub in, I'm going to have 11 squared plus 8 squared minus 5 squared over 2 times 11 times 8. Now, when you type that in your calculator, you come out with a fraction 10 over 11. That's because that's cos A is equal to that. To get A by itself, you need to inverse cos of the 10 over 11, which gives you 24.6 degrees. Please practice these calculator skills. I'm going over them quickly because it saves some time with the video, but please make sure that you can get these answers. Question 3. A motorist driving on level ground looks due north at a tower with an angle of elevation of 12 degrees. After driving a further 3 kilometers in a straight line, the tower is now in the direction north 60 degrees west with an angle of 14 degrees. How high is the tower? Okay, let's see if we can draw a diagram for this. This dot here, this is going to be my starting point. My motorist driving on level ground looks due north to a tower. So here is me going due north. Actually, I'm going to draw that slightly to the side so that I can see my tower from there, even though that should be north. There's my due north to my tower, and the angle of elevation to the top of my tower is going to be 12 degrees. So that little angle in there is 12 degrees, and that is my tower. After driving a further 3 kilometers in a straight line, the tower is in a direction of north 60 degrees west. So wherever I end up, so from here I'm driving somewhere in a straight line, and I have to end up somewhere that's north 60 degrees west. So north 60 degrees towards the west would be that way. So if we put it about here, there, then you could see if I draw my straight line from there to there, if I drive in that line for 3 kilometers, then it is north 60 degrees towards the west back to that tower. And the angle of elevation going up from there is going to be 14 degrees. Oh, let's see if I can draw that out here. All right, we need to put some labels on this diagram. So what we're trying to find is the height of the tower, so let's call that H. The triangle that I have on the bottom there, let's call that A, B, and capital C for those angles there. All right, so we've let the height of the tower be H. So what I can do is I can get, using the right angle triangles that I have here, so these ones here would be right angles because they're angles of elevation, we could get two expressions involving H there. So using this triangle here on the left, from the 12 degrees, the H is opposite, and the AC, I'm going to use the AC on the bottom, that would be the adjacent. So I'm going to use tan. Tan of 12 is equal to H over AC. That means I could get AC by itself, and that would be H over tan 12, doing the switch to get the H on the AC, sorry, by itself. Now let's do the same thing with the other triangle over here on the right. Again, H would be the opposite, and we're going to use BC, which would be the adjacent. So tan again. Tan of 14 degrees is going to be equal to h over BC. Now let's get the BC by itself. So do the switch, h over tan 14. Okay, now we want to get an equation that just has h in it. Now, we've got an expression for these two sides here, and we have the third side, which is 3. And we actually can get an angle as well. Remember that this line here, even though I had to draw it at a bit of a slope so I could do it on my diagram, that's actually going due north. And this here is due north, and I have that 60-degree angle there. So I could use the alternate angles to put 60 degrees into here. So now I also have an angle in that triangle forming the base of that diagram there. So I could use the cosine rule to help me relate all of those numbers that I've got there. So using the cos rule to find a side is what I'm going to do. So the side I'm going to be using is the 3 kilometers. That would be like the a in the formula. I'll write the formula down. A squared equals b squared plus c squared minus 2bc cos a. That's our normal formula, even though my diagram has a c on it. The 60 degrees and the 3 kilometers are going to be the a's in the formula. So a squared is going to be 3 squared equals, the b and the c are the other two sides, so b is h over tan 12 squared, because that's AC, this one up here that I found before. Okay, plus c, which is going to be this one squared, h over tan 14 all squared, minus 2 times, now I've got to times both of them together, h over tan 12 times h over tan 14 cos of my angle, which is 60 degrees. Now I know it looks terrible, but the only unknown in there is the h, which is what I'm trying to find. So all I need to do, and I say all I need to do, my goal here is to try and get that h by itself. That's what I'm trying to get. So let's factorize out the h's, because you can see in each of the terms that are on the right hand side here, I have got h squared, and h times h is going to make another h squared. I could factorize that out. So let's do that. 3 squared is 9. Let's factorize out the h squared. So from the first term, that would leave me with 1 over tan squared of 12. Plus, the second term, I've taken the h squared out, so it'd be 1 over tan squared 14. And then, for the third term, I've taken the h squared out, but I still have the 2, and I still have the cos 60, that would be times together. I can put those on the top. And on the bottom, I have got tan 12, tan 14. Close bracket. So to get the h squared, I need to do 9 divided by all that whole big bracket. Let's write it down again. Tan squared 12 plus, whoops, that's 1 over. 1 over tan squared 12 plus 1 over tan squared 14 minus 2 cos 60 over tan 12 tan 14. Now that is quite a bit to type in, so please give that a go. And that should come out to be 0.465100, more decimal places. Then I need to square root that to get h by itself, which is 0.681. 0.198, more decimal places. The question asks us to find the height of the tower. It doesn't actually tell me where to round it. Now, the reason that's such a small number is because the only measurement that I used in that was in kilometers. So that would be in kilometers as well, which might be more reasonable to give an answer in meters. So over here, I'm going to say, therefore, H equals, if I times that by 1,000, that would be 681.98, or I'm going to round that to be 682 meters to the nearest meter. Okay, part B. In what direction is the car traveling? So we want to know the angle in here. So that little angle in there that we're traveling. So I need to find the angle A. Can I find angle A? Yeah, well, to do that, I'm going to need to have some more sides that I can work with. I've got expressions for AC and BC, but they are in terms of H. Let's find BC now that we know what H is. So if I find BC using my formula, BC was equal to H over tan 14. That was one of the equations I had in part A. If I sub H into that, H was 0.68198. Remember, I'm keeping that in kilometers because everything is in kilometers in the diagram, not using the meters one, over tan of 14. So that's equal to 2.74 kilometers. Okay, that's that side there is 2.74 kilometers. So now, if I'm trying to find this angle in here for capital A, I've got the side opposite. I also have the 60 and the 3 kilometers opposite, so I could use the sine rule. So A over, I'm finding the angle, so I should do sine A over 2.74. Sine A over 2.74 is equal to, the other pair that I've got is the 60 degrees, so sine of 60 over 3. Okay, to get the sine A by itself times the denominator across the other side. So that's going to be sine 60 over 3 times by the 2.74. That equals 0.7896, and you'll need to inverse sine to get the final answer, which is approximately 52 degrees rounded to the nearest degree. Okay, we probably just want to write our solution out using the notation from the question. So it says, in what direction is it traveling? We were given a compass bearing of north 60 degrees west, so let's give a compass bearing for our answer here as well. So therefore the motorist is traveling on a bearing of, now the 52 degrees, remember, is this angle in here, 52 degrees. So that sloping orange line is north, so it will be north 52 degrees east. Or 0.52 degrees T if we wanted it as a true bearing. And that's it. You need to work on 6J.